Hey everyone, welcome back to another video, and in this video we're going to be discussing a new question that will be from the trees. It's a hard level question as per the LeetCode. The question is asking us to return the maximum path sum which is there in a tree. A question becomes hard in terms of understanding the intuition or the logic process because it's not that straightforward to get the logic in the very first go and write down the code. So that's the reason it comes in the hard category. Otherwise, talking about the code, it's pretty simple. It's not that difficult. After having the intuition in your hand, you can just write down the code for this question. So we'll see that what exactly is the thought process and how to approach this kind of a question. So the question is basically asking you to return the maximum possible path sum which is there in the tree. So that means as it is also having certain negative values, so that's the reason you have to consider that as well in order to get the logic for the question. And also, if the question would have only be having the positive values, then it would have become a little bit simpler. You just have to traverse the nodes and have to have some kind of a valid path. Then you can just return the whatever the maximum sum that you're getting at the end. And also the question is not asking you to return the path that you get. You just have to return the integer value. So that means over here the integer value comes out to be as a 6 2 1 3 after traversing all the nodes. So 6 is something that you have to return as the answer. So that's what the question is, and you have to build a logic. In order to build the logic, there are certain conditions, there are certain checks that you will be doing after traversing through the nodes. So the question is definitely you have to do through some kind of a recursion approach. That's how you will be traversing through all the nodes which are there in the tree. And the next thing is that you will be checking certain condition after reaching to every single node so that you can get your answer in the proper way. And also, like mentioned, that it has to have some kind of a valid path. So this is also something you have to check, and that's how you're going to be building your approach. So let me just give you the very simple example. So just imagine for a fact that you have one single node. Then what you will be doing? You will straight away be returning this particular number 2 because this is the only node that you have, and that's going to give you the answer because it's not connecting to any other node, right? So this is something that you will be returning at the end. Now, once the node is going to be having certain children, so that means 2 and 3 are connected, what will be your thought process? Because at this particular point you are not going to be just returning the root value. Definitely that can also be done, like if the condition is going to come in such a way that you have to only return the root value, then you would have definitely returned this particular thing, not these two. So the checks that I wanted to tell you is that there are 4 different conditions that you'll have to check. These are the 4 conditions that whether you just have to return the root value, whether you have to consider the left part, whether you have to consider the right hand side, or whether you have to consider the complete particular tree that you have, right? Whether the root value plus left, or root value plus right, or the root value plus left and right. So these are the checks that you have to do after reaching to every single node in the tree. So how will you do that? Why exactly is there a case that you have to check for these particular conditions? The answer is very simple. Let me give you the examples for that. Now imagine for a fact that you will be having this -2 and -3 as a nodes over here. What will be the answer? What do you think is going to be the answer? The answer is going to be number 1. You will not be taking these nodes over here. You will only be returning the root value itself, because the value that you're getting from the left hand side is negative, and if you add that to the root value, it's going to be reducing the value. So that means you're not going to be considering this thing. You don't need to consider the negative values, and if you're getting the negative values, you just have to return the 0. So that's the reason root value is something that you will be taking as your answer. And now from here as well, from the right hand side as well, you're only getting the negative value, and that's also going to lead to the sum as the negative one. So that's the reason the +1 is something that's going to give you the maximum answer. But now imagine for a fact that's the first condition. That's the reason you have to check for the root value. So the first condition is something that has been fulfilled. Now the next thing comes when you have to take the left hand side value. Why will you take the left hand side value? Just take for case instance, this is your +2 and this is your -3. What will be the answer? What do you think? So that means you will be checking and you will be putting a condition in such a way that whatever the value that you're getting from the left hand side or from the right hand side, which is the maximum one, that's what you're going to be returning to this root value. Okay. So that means plus 2 is something that's going to be definitely greater than that of this minus 3. And that's the reason you're adding this to the root value and you're returning that to your answer, and the answer becomes plus 3. Okay. So this is the very simple case over here when you have these two as the positive ones, and that's the reason you're summing that to the final answer as your plus 3. That's the similar case for the right hand side as well. If this would have been plus 3 and this would have been minus 2, then definitely your answer is going to be like 3 plus 1, which is your 4. Okay, so that's how you have to give it a check for the left hand side and for the right hand side. And now the question comes, how will you be able to update this thing, root value plus left plus right, and what exactly is the purpose? The purpose is very simple, because there can also be the case that the path is forming in such a way that you have to take the left, your root node, and the right hand side. So this is a very simple tree. That's the reason we are able to formulate the logic. We will see in this particular complex example as well that why is there a need of this particular thing. Okay, that's what we are doing. Okay, so like I mentioned, that this condition also has to be checked, and what exactly is the thought process. So the thought process is going to be very simple. You will take the value that you're getting from left hand side and also from the right hand side. You will add that to this particular root value. And what you will do, you will keep a global variable wherein you will be able to update that particular thing. So the global variable will be something which will be updated every single time whenever the value is going to come from the left hand side, from the right hand side. So that means all the 4 conditions will be checked, that whether the root value is also only something that we have to keep a look on, and whether the root value or the right hand side or this particular thing. Okay, so that means all the conditions has to be checked. So now that we've got to know that why exactly we need to have these 4 conditions checked, the reason is very simple, because it can also be the case that root value is only giving us the satisfying answer and these two are negatives. That's why we have to return this root value itself. It can be the case we have to take either of left or right, and it can be the case that we have to take the left, right plus the root value. That can also be the case. So now the question comes, because it's a very simple example, that's why we are able to understand this thing. But the question comes when we have certain complex things around it. Why exactly do we need to do all these 4 checks? Now just take, for example, this is your minus 10 and this is also your minus 9. Because when we will be traversing, it can also be the case that in a subtree, because this is a complete tree, it can also be the case that only in the right hand side there is a subtree which is creating a sum, which is creating a tree which is giving us the maximum value. So that's why we have to keep a check for every single node, that whether it is possible to create a subtree, whether it is possible to take the left hand side from this side and the right hand side from this side, and the root value, we have to keep on updating that to a generic variable so that we won't be missing any kind of a subtree inside of a tree, and that is giving us the maximum answer. So that is something also has to be checked. Now that we have checked this particular tree, we have stored this particular value in somewhere in a global variable, and whatever the possible path sum, like whether my 20 plus 15 is giving me the answer or 20 plus 7 is giving me the answer, I will be returning this to this, because for this particular node we are more interested in creating a particular path, whether like moving from minus 10 to 20 to 15 is giving me the answer, or whether from minus 10, 20 or 7 is giving me the answer. So that is something which I'm more interested in. So that's the reason we have to check for the maximum possible value, 20 plus 15 or 20 plus 7, which is giving me the maximum value. 20 plus 15 is giving me the maximum value, right? So that's the reason I will be returning this particular thing to minus 10. Okay, I hope this makes sense. And for this minus 10 as well, we will be checking all the possible situations, right? We'll be checking all the possible situation. Let's come back to the original example. If this is your plus 9, so this minus 10 is going to be checking all the things, right? Like from which particular place I'm getting the maximum answer, because this is also going to give it the plus 9 It is also giving us some kind of a value which is 35. So we'll put the condition that we will be adding all those things, and then we will be formulating our answer, that we will check all the 4 conditions for this -10. Whether by just returning alone this -10 I'm able to get the maximum answer. No, that's not the case. I can have certain better answers. Whether by just taking root value plus left it's giving me -1. No, that's not fulfilling the condition. I will check by just taking +20 whether I'm getting the maximum answer or not. So that's gonna give me like something called as 35. 35 minus 10, which is 25, and 25. So that's again, giving me the answer, but it's in a positive form, but that's not fulfilling the condition. So that means I will be including all these things, because by just taking +9 as well, I'm able to increase the something called as my chances, and that's the reason I will be updating this root val plus left plus right as well inside of my global variable. All right, I hope this makes sense. So let me just write down the code, and then we will see what all things are there. So I'll go back to the LeetCode over here, and let me just zoom this a little bit. Okay, so let me write down the code as well, and by this way I will be keep on just explaining you the things what we have discussed so far, what are the all 4 possible checks that we have discussed, so that we can have the logic in our hand. Okay, so this is basically my class, and inside of this class I will be making something called as my generic variable, and I'll call this as result. And inside of this result I will be storing integer dot min value. This is done basically in order to just have the minimum value which is possible in the tree, and then we will be just creating a new method. Let's say I'll call this as max sum, and to this method I will be passing my root node. Okay, so as of now we haven't done anything. We have just created a method, and we're just gonna be passing the root value towards that method. Okay, so this particular max sum method is not gonna do anything. It's just gonna be returning some kind of an integer value. That is, we're gonna be checking after every single recursion call. Tree node, that's gonna be my root value that it's gonna be taking. So what should be the base case? The base case is gonna be very simple, that if my root is equals null, then I straight away have to return the return value as 0. That's gonna be my base case. That's the very first thing. Let's go to the next particular logic. So like I mentioned, we will be having something called as the 4 conditions, right? First of all, we have to check the root value, we have to check the left or right, and we have to check the this particular thing as well. So this is something which is not possible to be returned, because it's going to be containing a complete path. So complete path is something that we cannot return, because a complete path is not going to be a valid path for the other nodes. It's going to be a unique path itself. So that's the reason we'll be storing its value to something called as our generic global variable over here, right? That's what we're going to be doing. Okay, so let's proceed further and write down the code. So okay, there is going to be my left variable, and that's going to be storing something called as my value that I'm going to be getting. Okay, so there is one thing, like I mentioned, there was an example which I gave you. So now imagine for a case, if the value that I'm getting from the left hand side is negative, whether I should be taking and adding that to the root value or not. I should not be taking that negative value, right? Because that's only going to lead to a bad answer. It's only going to reduce the value that we have to return at the end. So if the value is coming out from the left hand side is negative, then I can straight away make that to as 0. That's what we're going to be doing over here. All right, so let me write down that logic. 0 comma max sum, and that will be coming from root dot left. Similarly, I will be doing the same thing for the right hand side, which is math dot max. That will be 0. Max sum. Okay. So this is left and right that I have gonna be keeping a note of, that whether if the value coming out is negative, then I can straight away make that as 0. And if that's gonna be positive, then definitely it's gonna surpass, and that will be stored in this left and right. Now, next thing. So now imagine for a case that left and right both are coming as the positive ones. So I can have a possible path. I can have a possible subtree that's giving me the maximum value. So definitely that has to be stored. That has to be passed to the generic variable, and which is result. So the result will be updated. How it has to be updated? It has to be updated in such a way that result, I'll give it a check, and my left plus my right plus, what do we call this? And my root val. See, all these three things will be added up, and it's going to be keep on updating a valid possible path which I can have after reaching to a particular node, right? So that's something which needs to be updated inside of this root variable. Now, next thing. So what is the value that has to be returned from this method? So this method is going to be returning something called as whatever the value that I'm getting from the left hand side or from the right hand side, adding that to root val. So let me explain you what exactly this condition over here is doing. So this condition is basically, just returning a path, a unique path that we have got so far after reaching to a particular node. So now just take for instance for this particular example wherein, let me remove this a little bit. Okay. So just imagine for a fact that you are sitting at this particular node, right? So what you are demanding from this 20, this 20 has to return a unique path. It can be from 15 or it can be from 7. So when I reach to this particular 20 node, I check what is the maximum value that I'm getting from left or right. Obviously, I'm getting the 15 value as my maximum value. So this 15 plus 20 has to be returned to this particular 10. And that's what we are doing. Adding the root value and checking from left or right, what is maximum coming up, and that has to be returned. Okay. So this is what we are doing, and this will be returned. This will be going to the root node. Then again, minus 10 will be checked. This minus 10 will be, just again going to be updating the value to the result. Root value plus whatever the value that I'm getting from the left or right, that will be added up. That will be just updated inside the result, and that will be returned at the end. Return result, and let's give it a run. I hope this will be the answer and this will pass the test cases that we have. Okay, so we are getting some kind of an error. Okay, it's a syntax error. Let's try and submitting this again. Obviously it has passed all the cases. When I'll try to submit it, definitely it's gonna pass all the things. I hope this question was a little bit something you were able to understand, because it's a little bit tricky question, right? You might not get, though I have explained this, but you might not get this like for the very first time. Give it a thought, just give it a dry run, and then you will be able to get the logic. If you have any kind of a question, you can just definitely put that in the comment box. I'll try to answer back. And that's it from my side. Thanks for watching. See you next time.